All right, let's go ahead and get to work. You know the routine. Pause when you need to, fast forward and rewind as much as you like. Make sure you're taking notes. We're going to finish up our sixth and final form of energy today, so let's get our notebooks ready. Today we are talking about electrical energy, and our learning goal, our sixth and final learning goal is, I know that electrical energy is the flow of electrons. Give me your 3 boxes. Make sure you give me a scale score in the first box. When you're finished, go ahead and press play. All right, you should have been done writing down your learning goal. Let's get into it. We all know what electricity is. We've heard about electricity, but maybe we don't know what it is if you get down to the atoms. We've talked about in the past in our classroom about an atom. An atom consists of 3 parts: a proton, a neutron, and an electron. Think of that word electron and electricity. They have the same root word, and that's not a coincidence. Electricity, or electrical energy, is the energy of moving electrons. Now those electrons can move. So if you have 2 atoms next to each other, the electrons can actually jump back and forth. When those electrons move from one atom to another, you create electricity. Electrical energy is a very special form of energy because of how easily it can be turned into the other types of energy. Think about that. Electricity comes right out of the wall, and you can turn that electricity into sound. You can turn your stereo on, you can turn your iPod on. You can turn your electricity into heat, to heat your house or to make some toast in the toaster oven. You can use your electricity to create motion. Think of our electric pencil sharpeners. It's plugged into the wall, you put your pencil in, and that little machine turns around and around and around. And you can also turn electricity into light. Think of our classroom. The lights are on right now. So the great thing about electricity is it's so easy to change from one to another. And that's why humans, we love electricity, because we can make it do anything we want. Now we're going to learn later on in a few weeks about the 2 different types of electricity. But there's static electricity, like the kind you get when you go on the slide, make your hair stand up and you shock your friend. And there's current electricity, the stuff that comes out of the wall. Current electricity, if you've heard that word current before, like in a river or an ocean, it's the moving of water. Well, current electricity is the moving of electricity, or electrons. So here's what you need to know about electricity. Inside this energy stick, there's a battery. And the electricity, the electrons are stored inside the battery, and they want to get from one part of the battery around the wire into the other part of the battery. If you've ever looked at a battery, there are how many sides? 2, top and bottom. There's the flat part and the pointy part up top. The flat part is where the electrons come out, and the pointy part is where the electrons go in. Same thing here. There's a problem. The electrons can't get from this side to this side unless we give them a path, and that's called current electricity. So if I hold one side, the electrons can flow freely from the battery through my arm, through my body, and they can come out the other side. And as soon as I complete the circuit, it starts to make noise and light up and make a weird, funny sound. But the only reason that's happening is because the electrons can move. If the electrons don't move, you have no electricity. An electron sitting still does no one any good. Lights don't work, projectors don't work, spooky little sound tubes don't work unless the electrons can move. So make sure you know, when you're talking about electricity, current electricity is the movement. That's what powers everything. Static electricity is the electricity that's waiting to come out. That's kind of like when you go down the slide, you build up that static shock. So Bill Nye is going to explain it to us real simply, and he's even going to show us a picture, as an animation, of an electron jumping from one atom to another, and that's all that electricity is.
In the mid-1700s, Ben Franklin figured out the nature of electricity, paving the way for many more inventions. Electricity provides a way to store and distribute energy generated in a variety of there in 1903, the most common form of energy we use. In fact, you are using it right now. But what is this incredible energy, and how does it work? The answer lies in the atom. Atoms are made up of neutrons, protons, and electrons. Neutrons have no charge and protons are positively charged. Both stay in the nucleus, the center of an atom. Electrons are negatively charged and they can jump from one atom to another.
See it hopping from one to the next?
Electricity is the interaction of electrons and protons. Electric current is the movement of electrons from atom to atom. Lightning.
So that's what electricity is. It's the movement of electrons. And in the Bill Nye video, he showed you how the electron can hop from one to the other. Electron, electricity, electrical, it's all the same. So what do we need to do today? You need to look at the glossary term. There's two of them I want you to look at. There's one called current, it's for current electricity, and there's one for electric. Then there's a video about what is electricity, and good old Ben Franklin is going to walk you through his discovery of electricity and what it is. Once you have that, as usual, this is the sixth and final question. What is electrical energy in your own words? Don't copy the definitions. Be ready to have a conversation with me and explain to me what is electrical current, what is electricity, what is electrical energy. And then I want you to give me two examples of electrical energy in your day-to-day life. So don't give me the obvious about your TV and your computer. Try and think of something else that no one else in the classroom is going to think of. Where do you see electrical energy being used at your house, at a friend's house, on the way to school, here in the classroom, anything in your day-to-day life? If you have any questions, now's the time to ask me. If not, go ahead and get to work.